Hi, folks. Welcome to my talk here today. What's coming in FIDO? I'm Christian Brand. I'm a product manager here at Google. And for the next about 25 minutes, we'll be talking through some interesting enhancements that's coming in FIDO over the course of hopefully the next 12 to 18 months. So let's kind of like take a step back first and look at why we're even doing the work we're doing here. Phishing really is the scourge of the internet, and phishing has started taking over kind of like malware-based exploits around about 2015. And ever since that happened, it has really only been rising, right? Phishing has become one of the biggest and easiest attacks to pull off by bad actors on the web. Whereas malware, kind of like binaries, gets installed on machines, those kind of like, kind of the virus type stuff that we've been talking about has really been declining. And we think the primary reason for that is simply because phishing is so easy to pull off, right? Phishing is typically where some bad actor sets up a website. The website looks very, very similar to a real website. Like, for example, someone might set up a website that looks like real Twitter or real Google or real Facebook. They'll trick a user into going there, giving away their credentials, typically username and a password. And once the user has given it away, of course, they've now given it away to the bad website, and they now have everything they need to establish a session with the legitimate website. So essentially, they just hijacked your account. Incredibly easy to pull off. And we don't really have good solutions up until this point for solving that at scale. Solutions that kind of like came into play here are things like multi-factor authentication, typically things where not only do you need a username and a password to log in, we also send you a code or make you like approve on a phone. But the problem is most of these multi-factor technologies also suffer from the same issue in that a bad guy can trick you into typing your one-time passcode or doing your mobile approval on their website. And then again, they have everything they need. So it might slow bad actors down a little bit, but fundamentally, it's not solving the real problem. So that's why back in 2013, when we kind of started on this stuff and when Google got involved, we decided that we needed to do something about this problem. Kind of like something at the standards level. So this is bigger than just a single company. We wanted to do something at the kind of like global level where any company that want to participate can come look at some standards that we've worked on that can attempt to obviously address this problem. And really phishing was the main reason we set out. That's the reason why we set out to kind of start the work on FIDO. And later we got involved in a standard called WebAuthn, which is kind of like the standardized version for the web communication of FIDO. But in essence, W3C, WebAuthn, and FIDO Alliance together allows you to put a stop to phishing. And the way that these things kind of like interrelate again here, and many folks here would probably be well aware of this, we have like FIDO2 as our umbrella term up top. And then we have kind of like these different protocols at different points in the stack. Between a remote server and between a client, which is typically maybe a web browser or a computer or a phone, we have the W3C WebAuthn standard. That's typically what most folks here, I would imagine, would be interested in developing against. If you have a website or an app, that's kind of like where you would play on that leg between the client and the remote server. And then, of course, we have a standard inside of FIDO called CTAP, the Client to Authenticator Protocol. And that standard is mostly for what we call authenticator vendors. So if you're interested in kind of producing a physical FIDO authenticator, like maybe a security key, then that's the standard that you would build against to allow your devices to interoperate against any other client that's out there that supports the FIDO protocol. And then more lately, we have the built-in authenticator component. That's part of the operating system, mainly on these devices. So for example, on Windows, we have Windows Hello. On Android, we have the Android fingerprint subsystem. iOS has their implementation with Face ID and Touch ID. And that allows developers to utilize the built-in biometric and authenticator components of these devices without the need for any external physical security keys attached. Of course, physical security keys are still there for those who need them or who want them, but mainly nowadays, every single user has an authenticator built into their device directly, just because the operating system has a relationship with a key store and maybe some biometric components, which makes up the FIDO authenticator on that particular device. So many of you know this at this point. This is kind of like old news, and we've really come a long way since we started on our FIDO journey here a number of years ago with universal second factor, U2F, which was the security key protocol that allowed us to, in a phishing resistant way, authenticate users. You type a username, you type a password, you grab your physical key, you plug it in, and you authenticate. And then later on, and at some of these events, I've spoken before about the platform authenticators that we started kind of like deploying, which allows all Android phones from Android 7 or N and upwards to act as FIDO authenticators with the built-in biometrics. So that's already there. What we're going to be talking about today a little bit is kind of like the next generation work, which is coming with the WebAuthn Level 3 specification, where we are going to talk about what it would take to truly move into a passwordless world, and what it would truly mean for users to have like a full password replacement by means of FIDO and WebAuthn. So there are some things that's missing, and we're going to be talking through those things over the next couple of minutes here. So first, there was U2F, universal second factor, as I referred to earlier. The way this worked is user types their username, the user types their password, they insert their security key, they click a button, and magically they're signed in. And the reason why this is different from other forms of multi-factor authentication is, of course, because the physical security key would authenticate both the user, it would tell the remote website who you are, but at the same time, the remote website would also tell the security key who it is. So in other words, if you are connected to fake facebook.com, the security key would simply refuse to authenticate. It will only authenticate if the user is pointing to the correct web URL. And that was kind of like the big innovation here with U2F over and above other types of multi-factor authentication at that point. After that second bullet that we looked at on my timeline slide is the platform reauth flows. Basically, what that means is for the last 8 years or so, applications, ever since I think the iPhone 5S, who introduced fingerprint sensors on devices, were able to authenticate users in a passwordless fashion on the phone by just touching a biometric sensor. Now, this was kind of like meant to be a password replacement, but only once the user entered the password. So in other words, you can't truly get rid of the password, because every time you go to a new phone, you'd still go back and type your password. But once you've done it once, then from then on out on that same device, you can keep touching your fingerprint instead of like typing your full password. Like many banking applications and other kind of more sensitive services have adopted this technology. And then, of course, what we did with WebAuthn and FIDO is we brought these flows to the web. So we kind of democratized them. So it's not only a thing for apps on phones any longer. Any website that want to can now use the same functionality on the phones as well. And that's kind of what we see here on the right-hand side. If you want to access a sensitive part of like passwords.google.com, we ask you to re-authenticate by using your fingerprint. And really what's happening here behind the scenes is we're kicking off the WebAuthn flows. So that's something that's been out there for a number of years. Many major websites have started to adopt this, and we're pretty happy to kind of have taken the world from a place where once this was only destined for applications, but we kind of like taken it to a world where it now also works for websites. And the other thing is it works interchangeably between the two. So for example, if you authenticated in an app, you can go to the website for that app tomorrow. So let's say I download the PayPal app tomorrow. I can, go to the PayPal website, for example, and these keys are shared. So users authenticate less usernames and passwords, but they still didn't quite get rid of them. When you move to a new phone or something happens where, maybe the biometric sensor is dirty or whatever, like you kind of like still fall back to passwords. And that's one of the things that we're trying to address in this particular deck here today. What are the things we can do to truly move us to a world where you never need a password ever again? So as I said, we're not close to getting rid of passwords at this point, because every time you go to a new device, you still have to enter it. And we really categorize this as like 3 major problems that needed solving. 3 problems that are, what happens to FIDO credentials once you change a phone? Today, if you have a banking app on your phone and you've enrolled biometrics, when you go to a new phone and you download that app again, you're going to need to type your password again. And maybe you'll even need to do some kind of a second factor again. The bank might send you an SMS, or, you might need to go to an app to get a code. Fact of the matter is, like, there is no lifecycle management for these credentials on devices. Every time you go to a new phone, every time you upgrade or you lose a phone, you fall right back into the password trap. And the second one here is, how would you access these FIDO credentials from one device to another? So it's all great that I might have my FIDO credentials on my phone, but what happens if I go to my laptop and I want to sign into my bank there? usually what that means is I fall back to a password. I have to retype my username and my password, probably still have to pull out my phone because my bank might send me an SMS. I have to type that code back into my browser, and then I'm signed in. Like, how can we actually allow you to just move away from the password in this case? Because if you think about it, we have FIDO credentials on the phone at that point in time. There's really no point for us to fall back to passwords. And then lastly, one of the kind of like the final problems that needed solving here is today websites render users a username and a password prompt. That's what instinctively we all know how to engage with it. That's how we know we need to log into a website. When we see a little field saying username and password, we instinctively know what to do. In the FIDO world, there's not going to be usernames and passwords. And for a while there, we're going to have some users having usernames and passwords and some users having FIDO credentials. How do we construct the same UX, the same user experience from the website perspective to help users to know whether they should be typing things or whether they should be rather, clicking on a, sign me in with FIDO or doing something different here? So those are kind of like the three things I want to briefly talk through in this presentation today, and how we've been thinking about addressing them in future FIDO specifications. So let's start with the left-hand side. What happens when I change my phone? So we're thinking, well, one of the easiest things we can do, and we're going to experiment or kind of like illustrate this with our actor here throughout, Eliza. And imagine Eliza has a phone, let's say it's an Android phone, and she has some FIDO credentials on the phone. She got them by interacting with a website or with an app that created these FIDO credentials in the normal course of like using the application. What if we gave the device the option to allow this particular user to back up and synchronize their FIDO credentials from the phone to a cloud system where these credentials would be safely held? And when a new phone comes into the picture, Eliza would pretty easily be able to restore these credentials to a new device. Now, we don't want this to be secured with passwords, because you can imagine I have a phone today, maybe Eliza has an old phone, she loses it, she buys a new one. Well, how would she sign into the new phone without the old phone or without a password? So there are things today which we kind of like interact with on a daily basis, which is not password, but which are knowledge factors. One of them might be the lock screen on the phone, right? So every time that I want to unlock my phone, I can either use my biometric or I can use a lock screen, PIN pattern, or password. What if we allowed that to be the mechanism by which these FIDO credentials can be decrypted from the cloud and restored onto a new device? Now, clearly, we can't only use that. There's some additional information that we probably also have to attach to it. Maybe you have to prove ownership of a particular phone number. Maybe you have to prove ownership over an email address. The fact of the matter is, like, having some mechanism whereby you can get your credentials back from an old phone to a new one, we think is absolutely critical in this space for this technology to gain widespread adoption. Well, why is that? Because if you imagine with passwords, passwords aren't instinctively tied to a single machine. The whole point of a password is that they're portable, right? I can type my password here today, I know it, or I can write it down on a piece of paper, and if I go to a new machine, I can type it there again. So if we want WebAuthn and FIDO to compete against passwords, we really have to give a similar workflow. And we now know with password managers, that's exactly what they do. I can save my password on one machine, I can move to a new machine, and magically my password will just appear and I can use it. And that's kind of like part of the benefits of having password managers, and why most users nowadays have adopted password managers, because it just makes the whole workflow simpler, and it makes it more secure because you don't need to use the same password for anything. You can now have strong individual passwords for every website, and these passwords sync across your different devices. So what we're trying to do here is kind of like the same thing, where with FIDO credentials, which obviously are a lot stronger and they have these anti-phishing properties, but these credentials would also be transferred from one device to another, and kind of like backed up in a cloud environment. And nowadays with these technologies, we can do it in a way where it's kind of like end-to-end encrypted. So even though you're backing them up to a cloud, it's not like the cloud has access to these FIDO keys in the raw. So we're kind of encrypted with the lock screen, and the mechanism here allows you to move these keys around from one device to another. So that's kind of like, the first problem solved. We're thinking this backup restore functionality is something that we definitely need to try and add. The second problem that we spoke about is, well, what if I'm on my laptop and I want to sign into my bank, and I installed my bank's app on my phone and I have a credential sitting there? How does the laptop get to access my FIDO credential on the phone? Well, here, if we look at Eliza, kind of like a flow again, Eliza's trying to sign in on her banking website, and you now see there's no username and password prompt. There's actually a sign me in button there with a FIDO logo. So I'm going to click on the sign in button. And what we're going to start to see happen here is the user will see some mechanism whereby they can link their phone, which has the credential, to their laptop. And the way we're envisaging that to work is by the scan of a QR code. So you take the phone, scan a QR code. Maybe you click on that little login with FIDO button down there on the right. QR code scanning window appears. User scans the QR code. And once that happens, we can then relay the login instructions from the laptop to the phone. We're using Bluetooth for this. It's really important in the whole FIDO mechanism that there is local proximity connection between your laptop and your phone. Your authenticator and your client need to be physically connected. That's really there for the phishing properties, the anti-phishing properties to hold. So we're going to need Bluetooth here with old style security keys. It used to be a USB attachment, a physical attachment. We can't make the phone attach physically to the laptop. No one will have the right cables. So we're choosing to do this over Bluetooth. But essentially, you're linking the phone with a QR code, and then you're using this mechanism to send data from the laptop to the phone. You authenticate on the phone. You say, yep, I want to sign in on my phone or using my phone on this laptop. Over Bluetooth, the data is transferred, and then magically this user is signed in to the banking website. So remember, no username, no password needed on the laptop. We just made a connection with the phone, and everything happened on the phone, and the FIDO signature was sent over Bluetooth to the laptop so it can tell the remote web server that Eliza is present at this particular device. So now let's just quickly look at like how did these FIDO credentials get on the phone in the first place? That's always like a question we have. Well, remember, if Eliza had the TriBank app on the phone, or as in this case, she visited the TriBank website, that's her bank, on her mobile phone, when she signed in the first time, she probably entered a username and a password, or she had it autofilled. Like if she's using the password manager on this particular device, maybe her credentials were saved. So she just clicked on it, she clicked sign in. And once she signed in, she probably got some kind of a promotion, like some promo that told her that, hey, you can log in here much easier next time. You don't have to go through the whole motion of typing usernames and passwords. We can just register your biometric for you here right now. So if Eliza said yes, touched her fingerprint, a FIDO credential would have been created on the device when she opted in. So that's kind of like how we made this credential on the device in the first place. And once you make the credential on the phone, it's not only accessible only to the phone, it'll now be backed up, as we saw earlier, but also it'll be accessible over this Bluetooth FIDO protocol between any two devices where Eliza would interact. So whether she's on a laptop, whether she's on a tablet, you can always communicate to the phone using this new protocol that we're envisaging that'll allow FIDO to be accessible cross-device without physical attachment needed, like in the USB key case. Now, the very last question that still remains here is, how would a website know that FIDO credentials are actually available? That's one of the key issues when we look at designing websites and applications for FIDO. One of the key issues that we run up against is, well, how does the website know whether the user already has a FIDO credential? We don't want to serve everyone a login with FIDO button because most of the users at this point won't be aware of what that is, and they won't have FIDO credentials. So if they click it, they'll just be dropped somewhere with an error. And then again, for users who have FIDO credentials, we want to make it really easy for them to just sign in magically. So the question has always been, how do we make that easy? So in the first iteration here, we're thinking about like, why don't you just put a little button on the page? We should put a login with FIDO button. But as I said, if you put that button on a page starting today, imagine google.com were to put a login with FIDO button there. We'd get lots of users clicking that button, and they'd just be kind of like dropped with an error somewhere because there is no FIDO credentials for them. They've never made FIDO credentials. So, why would one even serve the button if users are going to click it and fail? So one of the solutions that a lot of relying parties were asking FIDO about is, can't you give us some kind of an API to tell remotely whether a FIDO credential for our website is available on a particular machine or a device? In the background, it's kind of like a transparent API. And the problem with that is that really doesn't fit well with the FIDO privacy principles, because we don't want the user's laptop to just leak in the background information on whether FIDO credentials are available or not. So we're kind of like stuck for a little while there. Like, how do we make the UX easy while not leaking some kind of like, privacy sensitive information about FIDO credentials being available for a particular website? So another problem with, of course, with a button like a login with FIDO, if we just were to add it there, we already have a lot of things for users to contend with, right? Today, if you look at this particular website, I'm not going to say whose website it is, but the font is fairly distinct. If you look here, like there's lots of buttons here already, or there's email addresses, and users get confused all the time. I know I do. I can't remember whether I used login with Google here or whether I used the credential that I made with the email address and a password, and users are just super confused. So just adding another button doesn't really seem like the right solution. So we're kind of like thinking, and we got together in FIDO with a bunch of other folks and trying to figure out what the right solution to this particular problem is. And really what we came up with was kind of like the following. What if we just had a simple button that said sign in? And when the user clicks on the sign in button, we take them to a username and a password page. But when the user goes to the username and the password entry page and they click into the field to enter their password, if a FIDO credential was available, either locally or on a phone that's kind of like linked with this device, we'll immediately bring that up. So this isn't a saved password. This is an actual FIDO credential that's available. And it's okay to list it here because we're not telling the remote website about it. This is all being done locally by the browser. So the browser comes up, the browser figures out whether a credential is available, and if it is, it'll serve it to the user alongside their saved passwords for this device. So a user like Eliza here would be able to see, oh yeah, I've got a FIDO credential available. Simply clicking on the FIDO credential would then make the connection to the phone, allow you to scan your fingerprint, and magically she signed in. So now websites have a choice. Either they can go with what we call the FIDO conditional UI over here, which will show the credential if it's available, or a website can still opt to have the actual discrete button if they wanted to, but both of these are now an option for this particular website to use. And we're suggesting that websites start off with a conditional model initially, where most users won't have FIDO credentials, and slowly over time more and more will have them. And then at a point where we've eradicated passwords and we've been super successful, at that point in time, we can simply move away and say, well, now websites don't even have to have a username entry field anymore because we know no one has usernames and passwords. We can just move to a button where a user can click something and magically the FIDO and the WebAuthn UI gets picked up. So that's kind of like where we ended up with those three problems we started out. And here we kind of talk a little bit about the technical details and how to make this work. Probably not as interesting to the audience here, but if you are interested, feel free to kind of like look at this stuff and also look. We'll see in the next slide here at some of the details of how to try this out on your own particular websites. So in summary, I want to end off here by saying FIDO is ready for deployment today. It doesn't yet enable full lifecycle passwordless experiences, as we've seen, because of the backup and restore functionality. But for general use cases, there are certain things that one can do. Phishing-resistant second factors and reauth, biometric reauth on web and app, those are all available today. We're working on addressing the gaps. We've identified them. We're working on addressing them. And really, over the next 12 to 18 months, we're kind of like hoping in the industry that most of these will get plugged. To kind of like end off with your, as I said earlier, if you want to play around with any of this stuff, there's a great server that IBM is hosting for us, howtofido.securitypoc.com. There's a document that we've put together in the FIDO Alliance that talks about how to use these different capabilities of FIDO today, also with a view on what's coming in the future. And then lastly, you can play with some code labs if you're interested to kind of like get really, really hands-on with the protocols and how that all hangs together. With that, thank you so much. Appreciate your time.